During load test, corresponding static and dynamic load data can be collected. Static load primarily collects deflection and strain. Dynamic load testing collects natural frequency and impact factor. Next, sort and evaluate the collected data. First, temperature influence correction. Bridge response data, such as strain during testing. All collected through sensors. Sensors are high-accuracy equipment, highly sensitive to temperature changes. Sensors during the data collection process of the test. Due to ambient temperature changes before and after loading, data collected by sensors, in addition to bridge response data, also includes data generated by temperature changes. While static load test only requires bridge response data. To ensure the scientific validity of the data, data obtained from tests, data caused by temperature should be excluded. Therefore, during the test, when testing bridge responses, can simultaneously test the bridge's response due to temperature. Facilitates the final exclusion of temperature data. Can also reduce bridge loading time. Avoid significant temperature changes during loading. Can also select periods with stable temperature changes. For example, conducting tests at night. Reduce, during the test process, the impact of temperature difference on test accuracy. 2. Support point settlement correction. Tests primarily measure the deflection variation of the bridge test section itself. During the test loading process, bridge support points will also experience some settlement. Support settlement will increase the deflection variation value of the test section. Therefore, final test section deflection data should be based on the test deflection. Exclude due to support point settlement, resulting in the correction value for the test section. Formulas are detailed in the Highway Bridge Load Test specification. Formula 5.7.3 A, B in the formula. Respectively, the settlement values measured at the two bridge support points. L is the distance between the two supports of the bridge. X is the distance of the test section from the bridge. The distance of one support point. C is the support point settlement correction value of the test section. 3. Residual value correction. The test measured value consists of elastic value and residual value. The elastic value serves as the basis for verification coefficient calculation. The residual value is the basis for calculating the relative residual. Test measured value. Relationship between elastic values, residual values, and before and after loading. Refer to Article 5.7.4 of the Highway Bridge Load Test Specification. 4. Relative residual. Relative residual of measuring point equals residual value divided by test measured value, namely, residual value plus elastic value. If the relative residual is smaller, indicates the bridge structure is close to elastic working condition. Highway Bridge Load Test Specification. As stipulated in Entry 5.7.8, when relative residual exceeds 20%, indicates the bridge structure's elastic condition is poor. The cause should be analyzed. If necessary, conduct another load test for confirmation. 5th, verification coefficient. Measuring point verification coefficient equals measuring point elastic test value divided by measuring point verification coefficient. Must comply with the Highway Bridge Load Test specification, as specified in Table 5.7.8. The smaller the verification coefficient, indicates greater safety reserve of the bridge structure. Generally, the verification coefficient of a new bridge is relatively small. Old bridges have larger verification coefficients. Dynamic load test content, including bridge natural frequency and impact factor. When the measured frequency exceeds the calculated frequency, can be considered as the bridge structure. The actual stiffness is greater than the theoretical stiffness. Otherwise, the actual stiffness is relatively small. Compare measured impact factor with calculated impact factor. If the measured value exceeds the calculated value, the cause should be analyzed. In the end, I will summarize this lesson. In this lesson, we mainly studied static load test data processing and the processing of dynamic load test data. Whether the data is correct, affecting the safety of the bridge. Therefore, when sorting and evaluating data, must not only be rigorous and conscientious, strictly comply with relevant standards. Additionally, a meticulous craftsman spirit is required. After class, please consider the following questions. What type of strain gauge installation method can be scientifically excluded? Deformation data of the structure caused by temperature changes.